Today we're going to look quickly, we're going to do a quick video on titrations where the base is the analyte. So hopefully up to this point, all of the lectures and videos you've seen are going to be where we've analyzed the acid using a strong base. So pretty much everything we're going to do today is just quickly flipped. Just a reminder, the purpose of a titration is to do one of two things: determine the concentration of an acid or base using a base or acid of known concentration. So today we're trying to determine the concentration of bases. We're also going to be trying to determine the equilibrium constant for a base, so the Kb value. So let's go ahead and get started. First things first, our strong base, strong acid titration curves. So just as a quick reminder, a titration curve is going to be where we plot the pH versus the volume of the titrant added. So in this case, it's going to be the volume of the acid. Usually it's in milliliters. And for these curves, for these graphs, we always start off where we'll either be at high pH or low pH. And because we're analyzing a base, we're going to start off with a high pH. And as we add acid, it slowly goes down. And then eventually you're going to get this drastic, sharp fall. And then it's going to level off again. The inflection point, which looks like it's about right here, I try to do it my best, is going to be the equivalence point. And the equivalence point, remember, is where you have the stoichiometric equivalence of acid and base. Is where all of the bases reacted with all of the acid. And for a strong base, strong acid titration, the equivalence pH is going to be 7. And the volume of acid that you added would be down below. Once again, the pH of a strong base, strong acid titration at equivalence is 7. So, as far as our strong base, strong acid titration curves go, that's pretty much it. These are going to be, generally speaking, stoichiometry type problems where you're trying to determine the concentration of a base using a concentration of strong acid, using a strong acid of known concentration, excuse me. All right, so moving along here, we're going to look also at weak acid, weak base strong acid titration curves. And these look very similar to above, where we're going to start off with a high pH. However, when we start adding, so that's plotting the pH versus the volume, once again, volume of the acid in this situation. So once again, we start off at a high pH, and when we add, there's a slight little dip and then it flattens out. And that's because as we add acid to a weak base, you actually begin to make a buffered solution. So this is here, this middle part is the buffer region. And then the acid, as we slowly make our way towards the equivalent, begins to dip again. And then it goes down to the bottom where we have a lower pH and then it flattens out. Now, very much like the weak acid strong base titration, the pH at equivalence for the weak base strong acid is not at 7. It's actually going to be below 7. So if our pH of 7 is roughly right here, we'll kind of extrapolate and say that the inflection point is roughly right there, and note that's below 7. So once again, the equivalence is where the inflection point change. So that's where the inflection point is. And the pH at equivalence is going to be below 7. Below 7. Now, continuing on, like most of the things in our weak acid, strong base titration lecture before, there were some important points. We could find the pH of the solution by doing a before-after table and then a Henderson-Hasselbalch equation. We could still do that with these ones here. And we also have the concept of the half equivalence point or the halfway point. And the importance of the half equivalence point, especially in the context of a weak base strong acid, is that the half equivalence point, so at the half equivalence point, the pOH is equal to the pKb. Unfortunately, though, I want to remind everyone that when we look at these graphs here, we plot not the pOH, but the pH. So the first and probably most important thing for you to recognize is where the pH is occurring at, and also to calculate the pOH after you do this. So if we're looking at the volume, the pH versus the volume, and we go ahead and calculate, here's our curve here. So we say roughly right here is where the equivalence point occurs. Then half, sorry about that, half the volume would be there. And this point right here would be the half equivalence or halfway point, half equivalence point. So in order to practice, we have a quick little question down below, and it says, what is the Kb of the base given the following graph, the following titration information? So we see here that the equivalence point is where we add roughly, 82 or 85 milliliters of acid, and it points out that the midway or half equivalence point is roughly right here. So we'll plot over to the pH curve, and then down. So looking at the halfway point, it looks like the halfway point is roughly where the pH is 9.5. Use your best judgment. If you said anywhere from like 9.3 to 9.7, you'd probably be within the ballpark. So that means that the pOH value, remember, if pH plus pOH is equal to 14, the pOH is going to equal 4.5. All right? For a weak base strong acid curve, the pOH is equal to the pKb. So the pKb is also roughly 4.5. And given this information, we know that Kb is equal to 10 raised to the negative 4.5. Punch this into our calculator, and we get that the Kb value for this is roughly 3.16 times 10 to the negative 5th. Wonderful. Thank you so much. Have a great day.